This is the equation for conservation of energy in sort of the simplest form. We have our initial kinetic energy, our initial potential energy, work done by outside forces, and then our final kinetic energy and final potential energy. This is a system in which energy is conserved, none is lost, all right? And as I talked about before, it's path independent. So if you look at this car, it doesn't matter if it goes through the loop-de-loop at the bottom or if it just goes the smoother path at the top, this is still the same equation still applies because it's path independent, and these are all scalars. If we look for loss in a system, where does loss happen? Well, one major place loss happens is friction. So friction turns kinetic energy into heat that's then dissipated from the system. You don't recapture that heat. So a big thing about electric hybrid cars is that instead of simply using friction to slow down the car, they actually run the energy back, the engine backwards and charge up the batteries when you hit the brakes, so that you're not losing all the energy. That's where a lot of their efficiency comes from, is when you hit the brakes, you begin charging the batteries again and dumping some of your kinetic energy back into potential energy in the battery rather than losing it all to friction like you do in a normal car. What's the other place where we have non-conservative forces? Well, think about a car crash. When cars crash, rarely do they simply bounce off of each other without changing. And so the work that goes into changing a car in a car crash is lost energy to the system, right? That takes energy out of the system. And so energy is not conserved when there are other things going on, like friction and work being done to deform things, like here, the silly putty hitting and going thud. It doesn't bounce because it just simply deforms. If you watch a ball, a bouncy ball, when it hits, it flattens out and then it springs back up because it is in part a spring. Putting in some other things, so we've got, now that we talked about non-conservative forces, we've got kinetic energy initial, potential energy initial, work due to non-conservative forces, other potential energy sources. I don't know what those are yet. That could be ones we haven't really discussed yet, like the battery in a car, gasoline, things like that. And that gives you your kinetic energy final, potential energy final, and whatever energy you left over final. A good example, again, back to the gasoline, you got potential energy stored in the gas. You burn some of it into kinetic energy. You lose some of that to drag through the air and other frictional forces. And at the end of the day, you've got your final kinetic energy, your final potential energy, and whatever gas you have left in the tank. All right, that's it for for conservation of energy.